the component to be tested, right? So you need 3 chemical agents. One is a cleaner, second is a penetrant, and third one is a developer. So these 3 agent, let me accept 2 more candidates joining the meeting. Okay. So these chemical agents are nothing but in form of spray. You can say, you must, I think, yes, the way you use deodorant and body spray, similar kind of spray is available in form of these 3 different categories. One is a cleaner. Okay, a cleaner you may use some sort of methanol or ethanol to clean the surface. So first, the surface to be cleaned. So we can make sure there is no dirt particle available on the surface to be tested. So first part is a cleaning. Then after cleaning, the surface is again made dry. So this surface is not having any dirt and foreign particles. And then after, the penetrant is applied. You can see here the penetrant. So a role of penetrant is that the chemical agent in such a way that the penetrant will try to occupy the empty spaces available on the surface. So wherever there is a void or there is a gap in micron, let us say there's a gap in micron, right? So the penetrant will try to penetrate in the gap and it will occupy that volume. So it will occupy the volume of that gap. So then after, the remaining penetrant on the surface has to be cleaned. So again, use cleaner to remove the excess amount of penetrant on the surface, and you see that the surface will be cleaned. Now, what is remaining? The penetrant occupied the volume having the similar volume of the defect. Now, how to detect on the surface? Means how we can visualize that this is the locations where the defect is existing. So then after, using a developer, okay, I suggest students not to do annotations on these slides, okay? I am going to disable this. Yeah, now no one can do that. I think you are mature enough. Second, then after, yes, developer. So role of developer is to develop the defect. Means a developer will do that whatever the penetrant is occupied in the gap or a defect, that will come on the surface. You can see here, after applying a developer, you will have the color contrast on that particular surface region. Here, you will not have any contrast, but nearby this defect region, this is a nearby surface. This is nearby surface. So here you will have this contrast. So by observing this color contrast, you can identify at nearby this surface, the defect is existing. But this defect is a surface defect. And you can see this, the way developer works, it's a mechanism of capillary action. So you will have this color contrast. Similar like the previous testing, magnetic particle inspection. LP test also cannot detect the cross-section defect. But here, the type of material to be tested is not an issue. In magnetic particle inspection, only ferrous material can be tested. Here, that is not the limitations. So you can test ferrous as well as non-ferrous materials. Now, next testing is a UT testing. I would say ultrasonic testing basically is a versatile NDT method. And here you can find surface defect, you can find subsurface defect or cross-section defects. That's why also you can detect for ferrous as well as non-ferrous material. So this testing basically is versatile technique. Now let us try to understand the principle, how it works. So as the name suggests, it is using ultrasonic waves. So here you can see that this is the transducer, or you can say it's a probe, right? And this probe basically is connected with the electric supply. Once you give the excitation, then this probe can develop the ultrasonic waves of particular frequency. So the frequency may be starting from 10 kilohertz, 20 kilohertz, and so on. So here it will develop the high frequency sound waves, and that sound waves you can use to test the defect. These probe are two types. One is a receiver and one is a transmitter. So in some of the testing, you may see two different probe. One probe would be transmitter. So they will transmit the waves to the workpiece, and second would be the receiver. But most of the cases you will have the transmitter and receiver as a common unit. So here in this schematic, the common unit is shown. So what you can see that a transmitter means you can see this arrow, this sound waves are nothing but the transmitter. They are transmitting. And this direction, you can see reverse directions moving towards upward. It's nothing but the receivers. So the ultrasonic probe, when it transmits the sound waves to the component to be tested, this is a component, let us say this is a pipe. This is a hollow cross-section pipe. And you can see this is a defect, flaw, right? You can see this is a flaw or defect is there. Now, this is not a surface defect. This is a subsurface defect. Or I can say it's a cross-section defect. So if I want to identify whether this pipe is having any defect or not. So here, the transmitter will transmit the waves, sound waves, and these waves will be transmitted throughout the cross-section, throughout the cross-sections, and then after it will reflect back. It will reflect back, and it will be received by the receiver of the transducer. So here you can see this is starting from this surface throughout the section at the bottom. So you can have this pico. Right? You can have this pic on the screen. So there will be a one screen. There will be one screen, just like a LCD, right? Electronic device. And that electronic device will give you the different signal in terms of peaks. So here you can see that this peak, the largest peak is nothing but showing that the ultrasonic sounds waves are transmitting throughout the workpiece and coming back. Now this probe you will be scanning. You will be scanning like on a just surface like this. Is a surface to be tested. I will be scanning manually. So when I'm starting from here and I'm moving here, and when the ultrasound waves make a contact with the defect before making the contact with the bottom surface. So what will happen when there is an obstacle in form of either flow or defect? What will happen? The ultrasonic waves will transmit from that point and receiver will receive. So strength of the signal will be reduced. You can see having a peak of lesser amount than this back surface. So when I'm having this peak, then I will understand at this point the defect is existing. And so on, you will be scanning the entire components to be tested. So if I have a very large section, 5 meter by 5 meter, let us say, then simply I can scan by using a multiple ultrasonic transducer, and I can have the information about the cross-section defect. That's why this UT testing is very suitable for on-field testing. Let us take an example, gas lines, gas pipelines, refinery pipelines. Once they install the big diameter pipelines, and when they do welding, right, joint welding, and they want to make sure whether there is a defect or not. So after welding on site, I will, let us say this example of welding, the two pipes being welded. Okay, Harshil. Okay, I will repeat. See, you will always have a peak. When you scan the component, the first peak you will have when there is no defect. So here you can see the waves are transferred from the top surface. There is no defect coming in a path, right? So we will have the back surface signal. So this back surface signal, basically it will be having the biggest intensity. When there is a defect, the intensity will reduce, and you will see at particular location that is a small amount of intensity. The echo is having a small amount of intensity. So we will understand that that is a defect. Now this initial signal is when, because you know that when you put this probe in contact with the top surface, there has to be some air. So this initial signal is nothing but when you make a contact of probe to the workpiece. So you will have this initial signal, but this initial signal is basically omitted. So best practice, the surface has to be lubricated. So we apply some sort of oil or some maybe fluid, because ultrasonic waves can transfer and give noise when it is air. So when you are moving this probe with having some lubricant on the surface, then you will have minimum noise. So you can easily identify the peaks of echo, and you can understand the identification of the defects. Right? So here the example is given, the welded piece at a center, there is a defect, and how it can be seen here over a defect signal. You can see the defect signal. And you can see the other signals. You can see it's a noise. Right? It's a noise. You can see the noise. So ultrasonic testing basically is a versatile, right? It's very easy to test, but the skill is required how you can interpret the defect. Based on intensity of echo, also you can quantify the size of the defect, right? So this is all about ultrasonic testing. Next one is a radiography testing, right? A similar kind of X-ray we used to do when we are ill, right? In doctor, when we go to the doctor, when we do radiography, X-ray, similar we can do for the metals or materials, right? So you can say X-ray has a industrial use in form of radiography. So it's very simple. You have X-ray source, right? The source, X-ray source having piezoelectric material, and then after you have X-ray film, And between the X-ray source and X-ray film, you have components to be tested for the defect. So what will happen? Let us say this is the component and the center one is a defect. So this is a defect. So once you apply the X-ray, so on a film, you will have the contrast. You can see here. And whether the defect is there, a defect means what? A defect means there is no any metallic components present. It's like a presence of oxygen, right? So you will have the color contrast on X-ray film. Here it's better to understand here. Radiography testing. This is the welded component. You can see the welding is a butt joint. And let us say this red point is a defect. It's a welding defect. So once this joint is exposed to the X-ray, source of X-ray, right? And at other side, you have the X-ray film, and that will give you the color contrast in form if there is any disturbance in form of defect. So you can see that the X-ray will pass very easily when there is no defect, but when it comes in contact with the defect, there will be obstacle. And on a radiography film, you can have that identification. This method is very quick, very easy, but it needs a high level of safety standard. So radiography is not oftenly used, but here you can see compared to this UT, ultrasonic testing. In ultrasonic testing, you have to make sure about the different level of echoes, right, when you are scanning. But in case of radiography, you will have the exact informations on a radiographic film. This is a radiographic film, right? So you will have the defect size indication. But radiography is not widely used. So these are the main techniques of NDT, right? Now we have some basic information about NDT. Now how we can compare NDT versus DT? This is a destructive testing, non-destructive testing. Destructive testing, you should always keep in mind that whatever the mechanical testing we have learned so far, tensile testing, hardness, toughness, fatigue, creep, all are the destructive testing. And non-destructive testing, whatever the four main processes we have learned today. Sorry, techniques, right? Four techniques we have learned, that is NDT. So obviously destructive testing where to use and non-destructive testing where to use, that we can identify easily. So here is the, I have listed. You can go through the advantages and limitation, but I will tell you the main difference of destructive testing and non-destructive testing is that destructive testing basically after testing, you cannot reuse the component, right? Because it will be a permanent failure. While in non-destructive testing, there is no disturbance to the final product. So NDT you can use basically on field. You want to take some decision for a quality control. When you are manufacturing something, your production line is going on, and you want to make sure, let us say you are producing 1,000 pieces every day. So in that case, NDT can be used to monitor the quality of the component. And destructive testing basically is more about developing the material on initial stage, right? That's why we go for tensile testing, hardness testing. So we know the property of the material. Non-destructive testing cannot give idea about the properties. So here NDT will give you more information on the defects instead of the properties. Here you will have the property flavor. And the other things, I think you can go through these points, and same recording I will upload by today, and you can replay it. So still we have 5 to 10 minutes, and I will unmute all of you now, and I will try to answer at least 3 to 4 students based on time availability. So now I'm going to unmute, and one by one you can raise your concern.
Sir, do we have any facilities for NDT in our university?
Yes, we have ultrasonic testing, right? Ultrasonic testing, then liquid penetrant test we can do, right? It's, you don't require anything. We have some, yeah, liquid LP test we can perform. MP test we do not have, but MP test I think we have ordered. It's supposed to be arrived in a March end, but because of this outbreak it has not come. But yes, when the university resumes, you will have MP and UT, magnetic particle and ultrasonic testing.
So, and this test can also be done by we can also make this test happen by some institutions where the service is available, right?
Yes, there are so many. See, I will.
There would be laboratories for that.
Yeah, basically also you can become an NDT certifier, because NDT provides some certification, level 1, level 2, level 3 in respective technique. Okay. Right. So yes, if you see, you are right. There are